Hello, Math 6. Here we are. The objective is to use a formal rule to multiply decimals. By now you have used the Desmos activity, and you have learned how to write, or how the idea of what it is to multiply decimals with a with the bar you've used. Okay, so today we're going to multiply. You notice that it says words, multiply as you would with a whole number. Multiply as you would with whole numbers, then count the number of decimal places in the decimal factor. The product has the same number of decimal places. So notice in this first one that there are 2 decimal places in 0.91. So there are 2 decimal places. So then there's 2 decimal places in your answer. There are 3 decimal places here. So there's 3 decimal places in your answer. Okay, that's our example in words. Now let's do a few examples of our own. So we're going to multiply these. How many decimal places should there be? I notice when I count them, there's 1 here and there's 1 here. So how many should there be? There should be 1 plus 1 is 2. I move 2 over, count 1, 2, and that's where my decimal place is. My answer is 20.54. You can do this, multiplying exactly the same way that you did before, only you're going to count your decimal places. 3 times 5 is 15. There are 1 place, 2 places, so 1, 2 places, and put my decimal, and I put a 0 out in front. 0.1515. Oh my gosh, 0.15 or 15 hundredths. I'm going to multiply just like I did before. 8 times 9 is 72. 8 times 4 is 32, plus 7 is 39, and the zeros don't mean anything, so I have gone over 3, 1, 2 here, and 1 here. That's a total of 3 places, so I'm going to move it over 1, 2, 3 places. When I get to the end, if it's on the end, I'm going to add a 0 to the front. So my answer is 0 and 392 thousandths. That is my final answer. My next equation, 4 times 15, 4 times 5 is 20. I put a 2 up on top and a 0. This isn't new to you, 4 times 15. You've done this before in other grades. What's different is the decimals. 4 times 1 is 4, plus 2 is 6. 60. I count how many decimal places I'm over. 1, 2, 3, 4. It's 4 on this one, and 1, 2, 3 on this one. So that's a total of 7. So I got to go over 7. 1, 2, 3, 4, 5, 6, 7. And that's where my decimal place is going to be. I have to fill in zeros for all of those places where there isn't a number, and put a 0 out in front so that it never looks confusing. It's talking about 0.000, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. I don't need that 0 at the end because it doesn't mean anything. We learned that a 0 after a number doesn't mean anything when it's after a decimal. So this would be my final answer for multiplying this decimal. Okay, next example, 4 times 5. So I'm going to put this over the top of each other, times 4. 7 times 4 is 28, so I put the 8 here and carry the 2. 4 times 3 is 12, plus 2 is 14, so I put the 4 there and carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 0 is 0. I'm done. I only have to do the numbers. Now that I'm done with the numbers, I'm going to count the decimal places. 1, 2, 3, 4, 1. So there's 4 and 1, so there's 5 decimal places. 1, 2, 3, 4, 5. That's where my decimal goes. I put a 0 out in front. I have to fill in with zeros. So the algorithm to this is not that difficult. The important part was that you understood why this was happening, and we did that in class. This is the algorithm. 0.012 times 18. And to be honest, it really wouldn't matter if you just did 12 and 18. You don't have to do both of these. If I just did 12 and 18, let's see what happens. I got 18 times 2, or 8 times 2 is 16. 8 times 1 is 8, plus 1 is 9. I have to put my 0 placeholder in for my tens column. 10 times, or 1 times 2 is 2, and 1 times 1 is 1. So as long as I remember to put that 0 in, so now I've gotten this kind of multiplication that I have, oops, I made a mistake there, huh? So 9 plus 2 is in fact 11. 1 and 1 is 2. So now I have 216, but I have to count my decimal places. 1, 2, 3 decimal places. 1, 2, 3 decimal places. 0.216. If I would have done it with the zeros in place, it would have come up with the exact same answer. So you don't have to write those zeros to start with. You can just take the numbers, multiply them together, and make sure that your final answer, you add in the number, you move your decimal over the number of decimal places that you have in each of the problems added together. The table shows the cost in cents of producing and distributing each coin for 2 years. Which coin costs less to make than they're worth? Which coin costs more to make than they're worth? How much more does it cost to produce 50 of each coin in 2007 than in 2002? Or 2000, sorry. So the table shows the cost in coins. So as I start to look at this, I might, this does not have a, let's just go here. I'm going to start with my 2000s, and it says which coin costs less to make than they're worth, which coin costs more to make than they're worth. So a quarter cost, this is the cost in cents. So a quarter cost 4 cents and 38. So this is in cents, not dollars. We're normally used to looking at, oh, I do not like this problem.